Hey, minasan, konnichiwa, Samurai Engineer desu. So in this video, this is the continuation of our discussion on the principle of design. We are on the main topic number 2. We just concluded our explanation about the foundation, then started something about the building components, then we will just proceed and continue with that discussion. So the last one, the last picture that we had, this is structure wherein we can observe proper column, good size of column. As an experienced engineer, I would say this size of column, size of beam is proper for this. I think this is a two-story building. Okay. So we have a gable, triangular gable with proper support of beams, cords, and so on. Okay. So this is a good design practice because we have a good pattern of reinforced concrete columns and beams to strengthen all aspects of building, including support for triangular gable and wall. So that is the triangular gable and wall that needs to be reinforced with the column to reinforce them, or they are liable to fall when the building is subjected to major lateral force. Lateral force meaning horizontal direction or slanting direction. That is example of those are wind, earthquake. So we are not talking of a destructive type of earthquake. Okay, the type of earthquake that we usually experience, that is almost a normal person that is moving or doing his daily activities would not notice. Okay, but the structure will feel the vibration of the earthquake, although normally we cannot notice it, no? Because that is a daily occurrence. We are used to it. Okay, so it is also has a reinforcement beam to top to all walls. Okay, so as you can see on that actual picture. Next slide, we have connection of wood frame to the concrete structure. Excuse. So how do we connect other type of materials into our concrete elements? So we have the following sample. We have brackets. We have here. This is how to connect our concrete to a wooden post. Okay, that is called post rather than column. Okay, wooden post connected to footings and foundation. Okay, so included in the foundation is this arrangement of what? Soil and soil component. So stones, rocks, gravel, without even the use of paste material like cement and water, we can consider as foundation. Okay, so this is this shape is what? Soil with a footings like this. So footings is like this one, and this is all foundation. So it involves what? The footing itself and the soil with this type of shape. This is how we compute the soil as a foundation. So that is computed on what? On geotechnical courses, not in this course. We will not compute here in this course. But we will remind you that this is related to that geotechnical course. Okay. So this one has what? Has essential wood frame structure mounted on a concrete brick stub wall. Okay, anchored. It is anchored. A bracket is usually used, made of non-corrodible material. Non-corrodible meaning it is not easily catch rust. Okay, must be casted into the bearing structure to provide a structural connection for the whole wall through to the foundation. Okay, so the wood column must be bolted to the bracket as shown. Okay, that's how we connect wooden elements to concrete elements. So we are now on design principle topic number 3, joining walls to roof structure. How do we do that? So column reinforcement should protrude from the top of concrete columns and be bent around roof trusses for structural strength. Okay, take note of that. All roof trusses should be strapped with metal ties to the wall structure. Okay, exposed metal should be painted with rust-proof paint to prevent corrosion. Okay, so those endpoints of the reinforcement that protrudes outside of the concrete, okay, so must be painted. Okay, so those are the main principle involved. So like this. So this protrusion must be painted. But usually this is not a permanent protrusion. This is just temporary protrusion because it is like this because they plan to extend it here on the left side and also on the right side. So this is the bracket portion at which it hugs the wooden roofing, for example, truss elements. Okay, so we have that example that is a connecting the beam and column to the roof trusses. Okay, roofing support. This is good for creating a very positive connection between roof trusses to building structure. Roof trusses should be constructed over columns. Okay. Okay. So this is the joint of the roof trusses, which is directly above the column. Okay, not here. Right? It's better for it to be above the column rather than solely for the beam. But the beam could still support it, but it is much better if it is supported directly above the column. Okay. So, and for a concrete column, the reinforcement should protrude at the top and be bent over. So, if there is no bracket, like this, you can extend the reinforcement from this column going down, going up here, and then bend it over and bend it like this, okay, such that in a manner that it looks like hugging it hugs the roof trusses. Okay, okay, so something like that. Okay. So metal straps or plates can be used for this role. So what we are seeing is actually strap. So metal strap, metal bracket. Okay. So in the next part, we are having an example. Okay. So we have what? Protruding metal part. Okay. This is a good example, but I don't think this is the reinforcement of column. I don't think this is the reinforcement of column. it is good if this is the reinforcement of column. So meaning to say this part is column, but it is not the joint of the roof trusses here. This is the joint. It's not directly in above the column. So we have what? The cord of the roof trusses. This is the cord of the roof is above the beam. I think I can see a column right here. So that is what? Okay. So it's still a good roofing sample of column steel reinforcement. So I was not able to see the column itself. Okay. So it seems that there is a column there. I cannot see the column. So meaning to say this reinforcement is an extension of the column reinforcement. And this must be painted. So there is no painting. So this must be painted. So that is for protection against corrosion. So there's a bracket or plate. So it seems that this is a column. So that is good because the column reinforcement is what? Bent around the truss. So I cannot see the column, but apparently there is a column. Okay. This is an essential detail in areas subject to earthquake and 2 inch to keep the roof on the house when a natural hazard strikes the structure. Such exposed steel should be painted. So that's what I said. To rust-proof paint to minimize corrosion. Okay, next one, we have the roofing itself. Okay, so the roofing, we have what? Okay, very good. Roofing. Okay, and it is supported by that. So there is no, can you see? So this is the, for example, again, I cannot see the column here. So supposed to be, there is a column here. So if there is a column here, so there is a beam and beam here. So there is a support right there, but I cannot see if there is a column right here. So the protruding extension of the column reinforcement must be bent. Okay, here must be bent over to hug and to brace itself in this part of the, in this joint of the roof trusses. Okay, so must be bent over. So I see this one or this one on this one. So I think this is not bent over but welded. So another example is welding. Not only bending or hugging or connecting in that manner, but can also be welded. No? So is another good roofing practice. Steel roof trusses are connected to columns through welding. So it could be welded. No? To truss member and purlins are welded with ties to roof trusses. So where is the purlins? This is what we call purlins. Okay, these are the purlins. Okay, these are the purlins. These are, and then that purlins are welded with this bracing. This is connecting brace, welded here and welded to the purlins, and also welded here at the bottom part. Welded connector. Okay, so I think this is not one single line, but this is what? Bracket like this. So letter U. I think this is letter U. Welded in this portion, welded in that portion, and welded at the top. Okay, so like that. Okay, so there is an inverted letter U or letter V here. Okay, so this one extend to the other side at that point. Okay, and at that point. So starting here, going to the other side and end at the other side. Okay, so that is the purlin. Okay, connection to the roof trusses. Okay. So next picture we have bad connection. Okay. So there is no protruding. The reason is there is no protruding steel reinforcement that what connects to the joint or to the truss element of the roof. Okay. So, incorrect roofing practice. Roof structure is good, but no connection. There is no connection. It's made between roof truss and building. The roof is resting on the top of the house wall and is subject to moving with high winds. So it will move. So that is the reason why we need to connect. There is no connection. Okay. That is why it is not a good practice. Okay, design principle, main topic number 4, about what? Tying walls to building structure. How to do it so that we can protect walls from being damaged. Okay, so under normal condition, under normal daily occurrence. No? So tying walls to building structure. Walls must be tied into the building structure so that they do not move separately when the forces of nature impact them. Wall ties should be hooked into the wall structure. Okay, hook. So there is a line. Hook is like this. Okay. So this is the shape of hook. Okay. Those are the simple principle in connecting the walls to the structure. So it could be connected to the column or to the beam. Okay. So this is an example of connection. Okay. So wall elements like hollow blocks, bricks, and so on have to be installed here. And look at the white portion. This white portion are the connecting elements, connecting the wall to the column. So these are wall and column connectors. Okay, so these white elements. And look at the shape at the ends. There is a hook at the end. Okay, there is a hook at the end. This white here are the connector for what? For door frame and wall connection, so that the door frame and the wall have to be connected to each other and they have to move at the same time. Okay, so meaning if the wall moves, the door moves at the same time, so they will not be damaged. Okay? So this wall would extend up to this portion, up to this portion, this portion. So they are connecting. They are the provision for connection. So good tying practice. This is an example for wooden frame. Okay, wooden frame meaning the beam and post are made up of wood, but the wall could be made up of masonry or hollow blocks walling. Okay, and we have an example where metal ties are used to tie wall materials to main structure of the building. Okay, so the ties are at maximum of 40 centimeter spacing or 400 mm. So 400 mm center to center distance, meaning this, if you measure this one up to that one is 400 maximum. This one up to the next is 400. Okay, 400 mm maximum. Good practice. About the next picture, we have again an structure. So now this is now connection again, same purpose, but now I think this is concrete beam and column. How to tie concrete beam and column to the walls. Okay. Okay, so concrete framing building. So previously that is wooden framing building. Okay. So again, the spacing is 40 or 400 mm. Minimum of 8 mm diameter. So use So use 8 mm diameter. So that is not used as an structural reinforcement, but in order just to connect the wall. Wall is not considered an structural element, but we can connect it through the use of, for example, 8 mm diameter steel bars. So you can have steel bars that with hook at the ends. So just create a hook at the ends. Okay. Okay, next picture. So we have what a good, very good column here with protruding provision for the wall. We have what steel reinforcement here. This is actually connector, not reinforcement, because the nowadays before that is called reinforcement, but nowadays reinforcement, the minimum reinforcement is 10 mm. So this connector could be 8 mm. So this is not a reinforcement but connector. So it can connect the wall to the column. So that is the difference of the word connector and reinforcement. Reinforcement meaning, according to the code, the minimum diameter of the deformed bars is 10 mm. Okay. So I think that is also in the Philippines, but we still use 8 mm. We still use 6 mm. Okay. But for connector purposes and for other function, not as an structural reinforcement. Okay. So here another example of protrusion so that it is prepared to be connected to a wall. So there is a plan. Okay, there's a plan for that possibility connecting it to a wall. Both beam and column supposed to have those type of provision. Okay, good example of wall ties cast into column to connect the walls with the building structure. So connector ties are to be at the maximum 400 mm from bottom to top of the wall. Okay, so 400 mm distance. Okay. $400 is about 1.5 feet. So our local carpintero will use 1.5 feet. That is almost the same, no? Almost the same. 400 mm. So actually, that is about 16. So 1 foot and 4 inches to be exact. But if you use what 1.5 feet, so that is acceptable. Okay, but still not, that is more than 400 mm. Supposed to be just maintain 400 mm and less. Okay. So look at the what? At this structure, wherein there is a picture where some of the wall components, okay, fell. Okay, some of the wall components fell, and also the beam fell. And you notice the beam do not have any connector to the wall. That is a bad example. Okay, okay, it's a bad example. There is no steel bars that connects the beam to the wall. Okay, so that is a bad example. So bad result, no ties. This is an example of what happens when walls are not tied to columns. They are not tied to columns and they are not tied to beam. Not only columns, they should be tied to beams and columns. Okay. The main part of this building, which to the forces of nature striking it, but the one floor extension collapsed. The columns could not help resist the force of nature on the wall of this house extension because of the lack of ties between the walls, okay, and the column. The one floor part also lack a strong structure. Okay, so where is the column? Here. This column, there is supposed to be a wall here this column should have a protruding connector here, and also in this in this beam is a protruding connector. So the wall collapsed, but as we can see, there is no connection of wall to the columns and to the beam. Okay, next. Okay. Of course, a very bad example. You can see there's no connection of this wall to this column. Okay? Okay? There's no connection of wall to column. Also, beam to column. To wall. Beam to wall. Okay? Wall to column and wall to beam. There's no connection. Okay? Bad example, lack of connector ties. Another example of what will happen when the walls are not tied to column. The wall panel on the left is moving away from the column because it has not been tied into the column. Okay, so that's all for the design principle number 4. We are now going to the, I think this is the last design set of principle, number 5, rope truss ties. So we need to tie rope trusses. No? Flexible but strong rope trusses enhance safety. The joints of wooden rope trusses need to be bolted together and tied with metal straps. Use metal strap. Okay. We are using rope ties. Okay. So, but if the rope truss is made up of what? Concrete, so continue the reinforcement. Continuous reinforcement. Okay, from column, from beam, there is a what? Connection. Okay, but if the rope ties is made up of wood or steel, so we can connect the column and beam to those elements by using ties. Okay, brackets. Okay, metal rope trusses must be welded by welding. Welded to purlins and welded to wall reinforcement for strength. Okay, so we have brackets like this, no? Brackets, steel brackets, okay? That is supposed to be connected to the concrete reinforcement, okay? By welding or bolting, okay? So a very good example, tying together the different elements of roof structure, okay? In this case, that is what? Wooden roof trusses. Another wooden wood trusses, but we have what? Steel brace bracket, steel plate, and this steel plate must have a connection, or this element must have a connection to the concrete structure frame. Another good example practice. So if we have metal, that must be connected to the metal roofing, connected to the concrete structural element. We have to what? Weld, okay, or brace using plate, using bolt, and so on. So in this example, this is welded. A good example, welding small brackets from concrete to steel elements. We still have design principle number 6, cross bracing of walls and roofs. Well, let us see if this is with respect to what? Concrete. So rope bracing of walls and roof. So in order to resist lateral forces, walls and roof structure need to be, so walls must steel. So the wall with hollow block wall, for example, that is not structural, but hollow block wall also have what? Connectors and reinforcement. So extend the reinforcement up to the what? Roof, so that you can what? Bend it around the roof elements. It's a major principle. Okay, major principle in traditional houses. Okay. So this one example, we have correct connection. Example of cross bracing. Cross bracing meaning we have what? Diagonal elements. We have diagonal elements. This one, diagonal elements. But this is not usually the case if we are using what? Concrete structure. This is for steel and timber. Okay. That's why we will go skip and go faster. So this is a masonry. No? This is an example of masonry. This is stone masonry. This I think in Batanes, warehouses usually experience typhoon and natural calamities, but they are very good masonry structure. Okay. Okay. So that is what we call masonry in comparison compared to concrete structure. So stone masonry. So as you can see, you have what? Frame. You have what? Column and then column and arch and column. So we have the structure frame here. Here and we have the stone walls. Okay. So good example, traditional Batanes houses which have stood many storms and earthquake. Okay. Solid stone walls on good foundation provide resistance to lateral movement. So design principle number 7, drainage principle. So there are environmental conditions around your lot, around your space. So you need to put up a good preparation for that. A high rainfall area requires drainage because it would what? It would create negative impact on the footings, on the foundation. No? Okay. So for roof water to common drain, levels of the drainage system need to be included on plan so that rainwater flows away and does not form puddles that breed insects and around houses. Okay. So what else? Drains should be covered or bridges were necessary to allow access over them for people and vehicles. So drainage, we can have a bridge or concreting on top of that, okay, so that we can move over those drainage properly and easily. No? Drain should have a V form at the bottom to reduce accumulation of water if levels are incorrect. Okay, so those are simple principle for drainage. Okay, let us look for the design principle number. So drainage is what are we going to talk about in what? In plumbing. That is the what? The plumbing. But you have to reflect it on architectural. That is already an architectural elevation, something, no? Plan. So, but the details must be on the plumbing. Okay. Design principle number 8, house elevation and location safeguards house and contents from flooding, landslide, and flash floods. So, we usually experience flash flood, meaning flash floods, meaning there are flooding, but after 5 to 10 minutes, the flood water subsides. Okay? The house floor should be elevated above the surrounding. So that's one measure, countermeasure for that. Okay, must be houses must be located away from places subjected to landslide. To protect from landslide. And those are two principles. Number 8 for what? Flooded areas. Okay, you are going to put up a structure on a flooded area. So you have to what? To elevate the flooring, the ground floor. Elevate the ground floor. So this is now the height of the ground floor. Okay, so that is now the height of the ground floor. You have to put up formwork so that you can what? Pour in the cement or the concrete on top of it for the slab construction. Okay. So good house elevation The house is being built in a low-lying area, vulnerable to flooding, but concrete stilts are being cast on pad footings to raise the floor level to the house so that it will not be flooded or subject to that. So what do we know about tilts? Where is the tilt? The tilt is this one.